Hello everyone, my name is Horace, and in this video we're going to be going through LeetCode number 21, Merge to Sorted Lists. For this problem, we're given the heads of two sorted linked lists, list 1 and list 2. We want to merge the two lists, list 1 and list 2, into one sorted list. This list should be made by splicing together the nodes of the first two lists. Finally, we just want to return the head of the merged linked list. As always, let's go through an example so we can understand the problem more clearly. So as you can see, for this example, we're given two linked lists, so list 1 and list 2, and I've written out the array representations of the linked lists on the side. And you can see at the bottom we have the merged linked list by taking and splicing together the nodes from list 1 and list 2. So you can see the first node is taken from list 2, and the second node is taken from list 1. The third node is also taken from list 1. The fourth node is taken from list 2. The fifth node is taken from list 1. And the last node is taken from list 2. And since we want to return a sorted list, we can just iterate through each of the linked lists as we need, since the linked lists themselves, list 1 and list 2, are already sorted. We want to check whether or not list 1 value is less than or equal to the list 2 value. So in this case, we take the smaller value node. So if this condition is true, we take the node at list 1, and if this is false, then we take the node at list 2. So if we take a look at the example again using this condition, we see that list 1 is equal to the list 2 node. So we can take either one. Let's just take the list 1 node, so we have 1 as we need. Then we iterate the linked list by 1, so we have the pointer here and here. So then we check, is list 1 value less than or equal to the list 2 value? Well, no, it's not. So then we take the lesser of the two. So in this case, we take the L2 value, and that's how we get 1 again. And then since we took the L2 value, we want to iterate the linked list, and we continue this algorithm until we get a sorted list. It's also important to keep in mind that we have some cases when dealing with linked lists. Since it's not specified the lengths of the linked list, we have three possible outcomes relating to the lengths of list 1 and list 2. The first case is that the length of list 1 is less than length of list 2. So this is a representation of how this would look like. We just have a node pointing to null, and the length of L1 is 1 and the length of L2 is 2. We can also have that L1 is equal to L2, and that just means that each of the nodes is valid when we increment the pointers. Finally, we have that L1 is greater than L2, and that's just the reverse of the first condition, and we have a null pointer earlier than the end of the first linked list. So there are a few ways that we can actually go about implementing this algorithm. One way that's pretty concise is using recursion. So just to be more clear, we can say that anything following the last linked list node is pointing to null. But if we suppose that the linked list pointer or the head is pointing at a null value, then we simply want to return one of the L2 values wherever the pointer is. Similarly, if the L2 pointer is at null, then we want to return the L1 value wherever the pointer may be. The reason we can do this is that once both are null, we already know that we exit the algorithm and we're done, because there's no more nodes to traverse. Finally, we have to deal with the condition when the list1 value is less than or equal to the list2 value. Instead of just returning the opposite node, so if it's true, then we return L2. If it's false, we return L1. We want to change the next pointer and recursively call the function so we can iterate the linked list. So suppose we begin with both the pointers at the heads of the linked list. Then we know that this condition is true, so we update the list1 next pointer for the first node. Then we recursively call on the next list1 node and the current L2 node. So in this case, we have 2 and 1, and this condition fails. So the next pointer for the first node is going to be evaluated based upon the recursive calls. Then you can see that this is exactly what we did previously. We are updating the pointers until we get to the null values. And it's also important to note that we're returning the respective list of the one that we're recursively calling. So if we update the L1 next, then we also want to return it. And finally, the linked list will be built recursively. The time complexity for this algorithm is big O of n plus m, where n is the length of the first linked list and m is the length of the second linked list. The space complexity is big O of 1, since we're not keeping an additional linked list to return the result. We're just mutating either the list1 or the list2. So with that being said, we can write the code for this algorithm. Okay, we're on LeetCode and we can start writing the code. So we can begin by writing the base cases. So we know that if either the list1 or the list2 nodes are null, we want to return the opposite node. So if not list1, that means it's null, then we want to return list2. And the same thing for list2. If it's null, then we want to return list1. Then we want to verify the condition and update the next pointers. So we can use the condition if list1.val is less than or equal to list2.val. Then we want to update the list1 next pointer if this is true, and update the list2 next pointer if it's false. So list1.next, and we want to recursively call this, so self merge two lists, and we call it with the next node and the current list2 node. We also want to return list1 because we want to also store the value in the previous next pointers. Finally, we can just update the list2 next pointer, and it's very similar to the list1. So we just change the list1 and then we call it recursively with the list2, and we return list2 at the end. And this is the entirety of the code, so we can try and submit it. And as you can see, it's accepted, and this is the optimal solution running in big O of n plus n time and constant space. So hopefully this video helped you and you learned something, and I'll see you soon.